Okay, so this video is going to be about slope intercept form. Now, this is one of those topics where if you remember the process, our goal, the product we're going to produce is going to look a lot like what we've done before. If you remember chapter 5 when we were graphing lines using equations, we were making input-output tables. I'm just making this up. We were making input-output tables. We were choosing values for x. We were plugging them in, things like that, seeing what they equal. So you remember us doing that back in chapter 5, and so that first one would tell us we have a point located at 1, 5. So we'd go and graph, go over 1, go up 5. So crash course is what I'm saying, and so for this one we'd have 4, we'd get 7. So 2, 7 would be our next one. So go over 2, up 7. So the old way we did it is we would do an input-output table, find a bunch of points, find out where they go, and then we would draw a line that goes through all of them. That was the old way we learned how to do it back in chapter 5, this idea of graphing with an input-output table. Now, what I'm going to show you guys is what we're going to do today is going to be the shortcut version of that. So that was just a really, really fast crash course and to remind you what we were doing before. What we're going to do this time is we're going to show a shortcut version of getting the same product, the same goal, we're going to create the same thing. We're going to graph a line, but we're going to do it so much faster. We're going to use it by doing skills using this format, slope intercept form. Now, before you get cranky and upset, why did I show it to you this way to begin with? It's because this method, you can't really understand it and use it unless you understand the old, longer way of doing it, so you actually know what does it mean to graph a line, period. So it'd be kind of hard to do this if you didn't understand how to do it that way. Okay, so y equals mx plus b. That is the template. That is the overall pattern. That is the most basic one. It's used the most. It's also it's the one that's easiest to read and graph and understand of all the forms of linear equations. We're not going to talk about the other forms. We're not going to talk about point slope, standard form, none of that. We're going to talk about slope intercept form. And it gets its name because of what's inside of it. And before I even talk about it, I want to show you guys, we've been doing it all along. That example you just saw me write a second ago, I think it was 2x plus 3, y equals that. That's an equation we've graphed before. That's an equation we've solved before. Hey, that's slope intercept form. Y equals some number times x plus or minus something. Plus or minus something. This is slope intercept form. We've been graphing this whole time without realizing the answers of how to graph it faster were right in front of us. So what we're going to do in this video, we're going to talk about how to use this shortcut to graph lines that are in slope intercept form. You know it's in slope intercept form when y is all by itself on this side of the equal sign. You'll have something times x plus or minus something. That's how we'll know that it is going to be slope intercept form. So here's what you need to know. A couple vocabulary words. One of them should be review, the other one maybe not so much. So now m is your slope. M is going to be your slope. And I'm going to try to keep them color-coded. M is your slope. Now remember what we learned about slope. We learned that slope, as a reminder, was vertical change over horizontal change. That's what slope is. I don't know why I wrote that full one out. Horizontal change. So now, just like some people call it rise over run, or change in y over change in x, or change in independent variable over change in dependent variable, or change in output over change in input, all those things I've just said all mean exactly the same thing. They're different ways of describing it. It's how much does it go up and down. That's the top number. It'll be a fraction. How much it goes up and down is the top, up or down is the top number. And the bottom number will be how much over it goes, how far over. Some of you might even remember the slope formula that we alluded to and mentioned too. It's y2 minus y1 over x2 minus x1. That's the slope formula. So we've always referred to slope as lowercase m, and that's how you're going to continue to see it referred to in other math classes. Slope is always going to be referred to as lowercase m. Slope, if you remember, or if you don't remember, check out chapter 5 video on slope. It is the measure of how steep is the line. Meaning, if I have a line that's diagonal like this, pretty steep, but if I have a line like this, that line is a lot more steep than the first one. It is closer to more vertical than the last one, so it's really steep. But at the same time, you could also have a line that goes downward, like that blue one. I know I'm making a mess down here, but I just want to give you an example. You can have lines that go down. So my green lines are going up, so because of that, if your line is going up, your slope is a positive number. meaning the fraction that is your slope, let's say I'm making this up, 2/3, it's a positive number. So if it goes up like that, it's positive, and we always read slope left to right. So this one is also positive. However, if you look at the blue lines, they're going downward. So these have a negative slopes, such as maybe negative 2/3, or really, really negative slopes that go down really steep like that. So negative lines going down have negative slopes. Additionally, what's right in the middle of that is if you have a line that goes straight across, level, horizontal, that line is right between going up or down. So the number that's in between positives and negatives is 0. So the slope of a horizontal line is 0. One final reminder, if you have a vertical line, a line that is straight up and down, so pretend that line is perfectly straight up and down. If you have that, it doesn't have a slope. It doesn't exist. We say it's undefined. So the slope of a vertical line is undefined. It doesn't exist because it has no slope. It's just a straight vertical drop. Okay, so that was a brief reminder of slope. We'll talk about how to count it and how to do it a little bit later. But if you need more details on slope, please check out the video in chapter 5 when we learned how to do slope. There's a video just on that. All right, anyways, this number that's in front of x, in this case over here it's a 2, that number that's in front of x, that is the slope of your line. That's how steep it is. If that number is positive like it is over here, your line's gonna be going upwards. If that number is negative, such as it is in the one I just wrote, I wrote negative 1/3, that's negative. That means that one goes down, that line goes downward like that, whereas this one, the line goes upwards. So I want you to realize that is your slope. It's right in front of x. So remember that. It'll always be in that spot as long as you have y equals something x plus or minus something. Okay, so now that was the slope business. Hopefully that was a good review of reminding you what slope is. Sorry for that long explanation, but I know some of us are still having trouble remembering or understanding what is slope. It's a rate of change. It's essentially the rate of change like we talked about, like this change stuff we said over here. Now let's go to the final thing you need to know. Slope intercept form. It's named after what's inside of it. You'll have a slope number inside of it, which is 2 in this case. You'll also have this. This is called your y-intercept. So that number that's going to be off by itself, plus something or minus something, that is going to be known as your y-intercept. Y meaning y-axis, meaning when you're graphing your y-axis, that's the one that goes straight up and down, your y-axis. So where your line crosses the y-axis, that location is called the y-intercept. So for example, let me make up a line. I'm making this line up. There we go. So I just drew a line, and I'll start with a different color. I'll start with a different line. That way we'll do 2 examples real fast. Okay, this first line, the green one, make that the first one. If it crosses the y-axis, you'll see it crosses right here. Whatever that value is, obviously I don't have any marks, so 1, 2, 3, okay, gave it a value. Whatever that value is, where it crosses, where it intersects the y-axis, that's the y-intercept. So if you count, that's 1, 2, 3, so that's y equals 3. So just now in that example I gave you, the green line, my y-intercept is going to be 3, which means positive 3, which means in our equation, it's like this one over here, where I said plus 3 plus the y-intercept, so it's plus 3, so the y-intercept is positive 3. So that means this value over here is the y-intercept. So your equation could look something like this, something times x plus 3. That would be an example of what it would look like. And the slope we'll talk about in a minute. But I just wanted you to help identify the y-intercept. Now look at this red one. The red one crosses down here. So we'll give it a value. So it looks like it's going to be negative 2. So that crosses the y-axis at negative 2. Because it crosses the y-axis at negative 2, that means the equation, I'm just going to make this up, y equals, I don't know, it looks like 1 over 2x. I'm making up the slope, I'm estimating. But where that crosses the y-axis, that's negative 2, which means this is going to say minus 2 right here. It's not going to say plus 2 here, it's going to say minus 2. Now that means the same thing as if it said half x plus negative 2. It means the same thing, but that's kind of silly to go through all that. If you just simply look at it and see that that's a minus sign in front of it, that makes it negative. That means it crosses the y-axis at negative 2. So remember, this is the positives are up here. The positives are up here, and the negatives are down here when we're talking about the y-axis. And on the x-axis, the positives are to the right, the negatives are to the left. So that's what I mean when I say y-intercepts. Now remember, I made up these equations just as examples, but now we're going to actually do some real examples to where we're going to start off by keeping it simple. we're going to start off by identifying what is the slope, what is the y-intercept from every single question. That's the first thing we're going to do. Once we know we're really good at just identifying it, there's no math, not math specifically, that's not really the right words to use, there's no calculations to do. You literally just point and say, hey, that's the slope. Hey, that's the y-intercept. So the slope is 2, the y-intercept is 3. The slope is -1/3, the slope is 4, +4. Literally, it's just like that. You don't have to calculate. You can just point to it and identify it. But yeah, there's going to be some special circumstances where it looks a little different. And those are some of the examples I'm going to show you. Like maybe we'll remember our basic skills about coefficients and denominators. So I just want you guys to know this is how we're going to start. We're going to start just by identifying what they are just from looking at an equation. But then after that, we're going to actually do some examples where we're graphing it, full-on graphing them. And you're going to really get to see how much faster it is to graph using slope-intercept form than it is to do with the input-output table, doing input-output for a few points and then hoping they're in a straight line, hoping to make any mistakes, and then draw your line through them all. You're going to like the way this is going to work. So stay tuned. Let's look at some examples to make it more in-depth. Okay, so on this slide, I'm going to make up an equation and we're going to graph it. That's what we're going to do. So I already had some coordinate grid paper waiting for us. So, I'm sorry, we're not going to graph it yet. We're going to do a few examples just identifying. So let's make up this first example. This first example is going to be, we'll call this example 1. Y equals x plus 4. Your instructions are going to say, state what the slope and y-intercept is. Actually, let me read it from your assignment. I'll read the exact words to you. It's going to say, state the slope and y-intercept for the graph of each equation. Meaning, if you were to graph this equation, what would be your slope and what would be your y-intercept? Normally, to do this, what we learned in chapter 5 is we have to do an input-output table, graph it, ... draw your line. And so you'd have like ... draw a line, and then count those things and figure them out. But there's going to be a much faster way, like we just learned. So if it says state the slope and the y-intercept, it doesn't matter which one you state first, but I'm just going to state the y-intercept first. So our y-intercept, it's +4 at the end, so that means our y-intercept, or b as we call it, as a reminder, I'll label it in the beginning, b, or the y-intercept, is going to be +4, meaning where this line crosses the y-axis is going to be at +4, so you'll see a blue dot there for that. Where it crosses is at +4. That's the y-intercept, because it says +4. If that had said -4, it would have been down here at -4. That would have been our y-intercept. Now, let's identify the slope. So if we identify the slope is the number in front of x. So don't forget, it's y equals mx plus b. The number in front of x is the slope. We'll look over here, the number in front of x. Hey, there is nothing in front of x. So I'm confused. Wait a minute. Remember, take a step back. Remember, ignoring the fact we're talking lines right now. Remember back just to equations and variables. If there's not a coefficient, what can you make that coefficient? Meaning, what can we assume it to be? And if you're still not sure what the answer to that is, ask yourself this. When you have something here, a coefficient touching a variable means multiplication. So ask yourself, if that's multiplication, okay, if there's nothing there, what can I put there that won't mess me up? So ask yourself, what can you multiply by that changes nothing? Can't say 2, because you multiply by 2, you just double the value. But what if you multiply by 1? If you multiply by 1, that doesn't change anything. So it is safe to put a 1 in front of that x. 1 times x is just x. So there's an understood 1 right here. So now you've remembered, oh, that's right, that's what's in front of a variable if I need there to be something. It's a 1. So that means the slope of our line, or m, I'll label it as the slope for now, although in the next few examples I'm going to stop labeling it. I'm just going to start writing m. M is 1. Our slope is 1. But in the beginning, let's get in the habit of referring to our slope as a fraction, so we always know what the top and bottom numbers are, so we have no doubt about rise over run, or vertical change over horizontal change. Let's go ahead and be more specific. Let's keep it a fraction. And if it's not a fraction, now you have to use that other assumed 1. Anytime you don't have a denominator and you need a denominator, it's at a 1. Because you ask yourself, what can I divide by that changes nothing? What you can divide by in this case is 1. 1 divided by 1 changes nothing. It still equals 1. Now, if this had been a 2 up here, and we would have a 2, we'd have 2 over 1. Because 2 divided by 1 is still 2. So it's a fraction, but it's still 2. So our slope is 1 over 1. 1 over 1. Let's review what that means. The top number, because it's positive, means go up 1. The bottom number will always generally be, if we have a negative, we're just going to associate it with the top number. The bottom number is 1, so that means we're going to go to the right one. It's always to the right, it's never to the left. And if this had been negative, this would have been down 1. So we're actually, let's go ahead and just graph this one. We've already given it the visual at this point. So before we do though, I'm going to do one more example of identifying, I'll do it on this screen, of identifying some of these. By identifying, I mean identifying the slope and the y-intercept. And then we'll graph them both on the same graph, even though it's kind of silly to put them on top of each other. We're going to do it anyways, just to make a point, to make sure we're doing it correctly. All right, so let's see. Let me make up another equation over here. I'm going to call this one okay. Y equals negative 2/3 x minus 4. Okay, so I'm actually going to change that so it fits on our graph a little bit better. That's going to be down at the bottom. So let's say minus 1. Sorry if you already wrote that down. Okay, so in this example, we're going to graph this one, but before we graph it, we're going to do what we just did over here. We're going to identify what is the y-intercept, what is the slope. We're going to do the same thing. So now over here, let's identify what the y-intercept is. The y-intercept is that thing that's plus or minus off by itself. So that's this thing. It says minus 1, so that means it's negative. So that means our y-intercept, or on B, I'm going to still call it y-intercept, but after a while I'm only going to call it B. Our y-intercept is negative 1, which means where this crosses the y-axis, where this one crosses the y-axis, that's going to be negative 1. So this is the y-axis, goes up and down. Negative 1 we see is labeled. They're not always going to be labeled on yours, so you need to know the negatives are down here. So y equals negative 1 is right there. So that's where that line of that equation is going to cross the y-axis. Now let's find the slope. The slope is the number in front of x. So the slope is negative 2/3. So now that tells us our slope, I'll even label it as slope, is negative 2/3. Now let's interpret that. That means negative 2, so that means down. So that means down 2, and 3 means to the right, 3. So that means we're going to go down 2/3. That's how we interpret that slope. So we just did 2 examples where we identified the slope and the y-intercept, or y-intercept and slope, the order doesn't matter. So now that we've identified slope and y-intercept, we're now going to graph both of these. And again, we're going to do both on the same graph, so you can just see them side by side like that. But we're going to go ahead and graph both of them. So just so you know, anytime you graph, step one is graphing is find your slope and your y-intercept. That's step 1. Now, step 2 is graph your y-intercept, or B, graph B, since that is the y-intercept. Step 1 was find slope and y-intercept. Step 2, graph the y-intercept. Step 3 says we're going to graph the slope. This next part's important. From the y-intercept. That's very important that you do it from the y-intercept. So I'm just going to say from B, so we have room. So from B. It's very important that you make that connection, that when we go to graph the slope, we have to do it from the y-intercept. We can't do it from the origin. Okay, once you do that, you'll have 2 dots. So step 4 is just draw your line through those 2 points. Just draw your line. Okay, so now let's do each of these examples. So step 1 was find m and b. For this equation, we already did find m and b on the left. So now step 2 was graph the y-intercept, graph b. We already did that. That's the blue dot. So we're on to step 3. Step 3 says graph the slope being up 1 over 1. Graph that for the reason we said earlier. Go hit rewind if you forget why. Graph the slope. So that's up 1 over 1. But it says from b, from the y-intercept. So, by the way, it's called b just for cause b. Most of the world calls it b. Some people call it c. But m, everyone calls the slope m, just as a side note. Anyways, back on. So from the y-intercept, we've got to go up 1 over 1. Okay, so from the y-intercept, we go up 1 over 1. Okay, so we're going to be right here. So we now have 2 points. You need 2 points to draw a line. You're now ready to draw your line. You're actually kind of at the finish line for number 1, for that first example. So you're going to draw a line that goes through that question, that goes through those dots, excuse me. So let's see. I'm going to try to draw a long line that goes way through them. Okay, so that line goes through them. Yeah, let's not poke into that question. Okay, so it should keep going, but I went ahead and I didn't want to poke into the next question, but that blue line can keep going all the way until just draw arrows on the end of it. There's arrows on the end of it now, but just so you can see them, I'll add them on there nice and big. So you now have drawn a line. It doesn't have to be a dotted line, I just needed a blue line, that was the only one available. So okay, we drew a line through those 2 dots, you're done. If you're worried about how crooked or straight your line is going to be, use a ruler, use the edge of your calculator, use the edge of a pencil, paper, or you can extend your slope. You notice when it was up 1 over 1? Feel free to go up 1 over 1 again. Go up 1 over 1 again. Or if you can get your brain to think, go in the opposite direction, down 1, left 1, you can kind of trace out a slope so you can have like a little dotted trail to follow with your line. But just make sure you draw a straight line, as straight as you can, going through those points. You're now done with example number 1. So now let's hit up example number 2 over here. In example number 2, step 1, identify slope and y-intercept. We already did that earlier. Hit rewind if you can't remember how we got those. Now, step 2 is graph the y-intercept, graph B. We already did that. The y-intercept was -1, so we cross the y-axis at -1. That's where we cross it. Step 3 says graph the slope from the y-intercept. Okay, so from here, we're going to graph our slope. Our slope was -2 over 3, which we talked about. That means down 2 over 3. So from this location, we're going to go down 2, now over 3. I'm showing my dot to show you that I'm counting. So that means it's going to go right here. So down 2 over 3. We now have 2 dots to where we are ready to draw our line that goes through these 2 dots. Now feel free to extend it again if you want to go down 2 over 3 again to help you see it and visualize it. Otherwise, just use your ruler, edge of a paper, calculator, whatever, to help you draw this line as straight as possible. So this one's in red. So what do I got in red? I have that one. Okay, so I'll use that one. All right, so I'm gonna draw mine that goes through those locations. All right, I'm gonna do my best to line it up. Oh, I am not using the line tool apparently. Let's hit back on that. Okay, line tool. Oh, I see, I never hit the line tool the first time, I'm silly. Okay, all right, try this again. Try to line up the best you can, going exactly through those 2 dots. Okay, there we go. All right, so that's a nice straight line that goes through those 2 dots. And so draw an arrow on each end of your line because you're indicating it goes on forever. You're just happening to show a piece of it. So now at this point, we have drawn the line that goes through those 2 dots. You're done with this question. You now have graphed this equation, y equals -2/3 x minus 1, because you know the y-intercept was -1, you know the slope is down 2 over 3, so from there you went down 2 over 3. So these 2 equations, we now have a very clear, 2 clear examples of how to graph lines, some with positive slopes, some with negative slopes, some where the slope was an understood 1, and some where the slope was negative, positive y-intercept, negative y-intercept. So I try to give you some examples of all the possible ways that these questions can be asked. Sometimes there might be a combination of both. So take your time. I'll do, I'm not going to do any more examples of full-on graphing these from scratch. I think that these 2 really broke it down for you. But what I am going to do is we're going to do an example together, like a word problem. There may be some word problems using this information. That's what we're going to do now. So in terms of just the actual calculation, there's no calculation, just the actual graphing skill of itself, hit rewind and watch these again if you need to hear it again. But now I'm going to actually do an applied problem. We're going to actually look at an example. Okay, so we're going to do these 2 questions on the screen, and after these we're going to call it a quit. We're going to call it quits. That'll be the end of the video. So at this point we're going to do now an applied problem showing you one example where this skill can be used in a word problem. That's what we're going to do. Alright, so this question is all about traveling. It says, for exercises 3 and 4, use the following information. Quentin is following information. I forgot to pause for that period sign. Quentin is driving from West Palm Beach to Gainesville, a distance of 270 miles. He drives at a constant speed of 60 miles per hour. The equation for the distance yet to go, meaning how much further he has to go, is y equals 270 minus 60x, where x is the number of hours since he left. Now notice, since he's left, so if he's driven for 1 hour, he's gone 60 miles. If he's driven for 2 hours, he's gone 120 miles. If he's driven for 3 hours, he's gone 180 miles. But notice, if he already knows he has to go 270, they're subtracting because that's how you would find out how many miles are yet to go. You would do how far total minus how far you've gone. That's why this is a minus situation. So this equation, to help it put it in the format of what we're used to seeing, I'm gonna write in a slightly different order right under it. That way it's in the form of y equals mx plus b. Because right now it's in the form of y equals b plus mx or minus mx. So it's written in a slightly different way. So right below it, let's change the order of that. And if we do, that's gonna be written as y equals negative 60x plus 270. Now, we know that it's negative 60x because of the minus in front of it. So that's why it's negative when we did this. The 270 is positive, so that's why it's plus 270. So all I've done is, it's just like saying 2 plus 3 is the same thing as 3 plus 5. All I've done is change the order of this so to help you see it in the same form we've been talking about, in the form of y equals mx plus b. So that's what we're gonna do. We're gonna graph that equation most likely. That's probably what they're gonna ask us. So let's look at question number 3. It says, what is the slope and y-intercept? Explain how to use the slope and y-intercept to graph the equation. Then graph the equation. Now the step where it says explain how to use the slope and y-intercept to graph it, realize that's the steps that we just talked about, that we wrote down. Step 1, identify them. Step 2, graph the y-intercept. The y-intercept is like your anchor. Step 3 is to graph your slope from your y-intercept so you can get a second point, because you need 2 points in order to make a line. So if you have your y-intercept and you have your slope, graph your slope from the y-intercept, and now you know the pathway of the line, so just use a ruler or something and draw a straight line through those 2 points. So that's kind of the process of how to use the slope and the y-intercept in order to graph it. Okay, so now we're gonna actually, what is the slope and the y-intercept? Now that I put it in this order, you probably can answer those questions really easily. The slope of this line is m equals negative 60. So the slope is negative 60. M equals negative 60, so the slope is negative 60. Now if you need to throw that over 1, throw that over 1 to help you understand it's negative 60 over 1, which means it goes down 60 and then it goes over 1 on the graph. That's what it's going to look like. Now putting that into words, that means it goes down 60 miles every time the hours go up by 1. So using words, we would say the distance remaining goes down 60 miles per hour, or down 60 miles for every hour. That's the distance remaining. Okay, so that's our slope, and we've also kind of talked about what it is in words. Now, let's talk about our y-intercept. Our y-intercept, or b, our y-intercept is, it says plus 270, positive 270, so our y-intercept is 270. That means where it crosses the y-axis, excuse me. Okay, so 270, since that's our y-intercept, that's going to be where it crosses the y-axis. Sorry for that interruption. So that means where this line is going to cross the y-axis being the one that goes up and down, it's going to cross right at 270. That's what that tells us. And that actually makes sense. That means at 0 hours of driving, remember this is time spent driving, at 0 hours of driving, we haven't gone anywhere yet. So if we haven't gone anywhere yet, we still have the full 270 hours left to go. So intuitively, that makes sense. And in fact, I think I just explained what the y-intercept means. So if it asks what the y-intercept means, I want you to know what the y-intercept means is after 0 hours of driving, you still haven't gone anywhere, so you still have the full 270 miles left to go. Okay, so remember, step 1 was of graphing equations. Find your slope and y-intercept. Step 2, graph your y-intercept. Step 3, graph your slope from the y-intercept. So from that y-intercept, we're gonna go down 60 over 1. So to go down 60, so we don't go, these don't go by 60, or they might, but we gotta check. It goes from 90 to 180, so that means it goes up 90 in 2 blocks, which means 1 block is 45. Okay, so that tells us 1 block going down is 45, but we've gotta go down 60. So if we go down 45, we got about another 15, so that's about a third of it. So that's about right there. That's about going down 60. That's where about 210 is. 210 is about right there. And so in over 1 hour. So now do your best when you graph this. So that's going to tell us that's going to be right about there is where that's going to be. Now from there, we're going to go down 60 and over 1 again if you want to, or that right there is enough information to graph it. You have 2 dots. Just estimate. I realize you couldn't quite tell what was down 60 according to this graph, but if you really look at it, you'll see, okay, going down 60, that means each box is worth 45, so 60 is 1 box plus a little bit more. In fact, it's exactly 1/3 of the next box, so that's a pretty good estimation. I'm pretty proud of that. So now your job is simply to now draw a line that goes through both of those dots. So draw a line that goes through both those dots. Make it as straight as you can, going all the way down. Now that you've now answered the question, you have now used the slope and the y-intercept to graph this line. So at this point, you're done with question number 3. We have fully graphed it. Now, in question number 4, they're asking us, what is the x-intercept? What is the x-intercept, and what does it represent? Now, off my estimated graph, it looks like it's about 4. But let's be honest, my estimated graph, I can see that curves a little bit. I didn't fully use a ruler. And I was estimating where that point goes anyways. So to be more precise, we can find some of those other points if you're concerned about it by making an input-output table. For example, if we want to know what's going on at 3 hours, like maybe I want a more precise answer at 3 hours or 3.5 hours. As a side note, yeah, use your input-output skills for questions like these. So let's make, remember, x was the number of hours. So that's what we can do. So that means let's make that 3. So we would have negative 60 times 3. Well, that's a negative 180 plus 270. So or we could have done 270 minus 180. Same thing that way. So negative 180 plus 270. So that's going to put us up into the positives. So that's going to be, my brain's slowing down on me. So let's see, 270 minus 180. That tells us 90. Oh, duh. 90, 180, 270. All right, anyways, so that's positive 90. So positive 90. So that tells us at 3 hours, we still have 90 miles to go. So that means at 3 hours, we should be at 90. So you'll see my curved line, I actually missed a little bit because I wasn't apparently accurate enough. And so when you're drawing these, if you have any doubt, like if you have a graph like this where you had to kind of estimate where those dots go, maybe find one of the dots the old-fashioned way to confirm that you're going accurately where you need to be going. So my line should have been more along that route. So I'm going to adjust my line and straighten it out a little bit. Okay. So now it looks like our x-intercept is going to be maybe closer to 4, 4.5, so somewhere around there. Okay, but we can be precise in finding that. And now let's answer number 4 and be precise when we answer number 4. What is the x-intercept and what does it represent? Meaning, put it into words. What does it mean? Now, before I go into it, I want to briefly remind you, not remind you, but maybe show you something. If you got a graph, I'm going to sketch this graph. So that's my y and x-axis, so that's my y-axis, that's my x-axis. So I'm going to make up some points. Okay, so if I have a line, and my line crosses the y-axis right there, and it crosses the x-axis right here. So I'm making this question. This is not one of these, but I'm showing you a simpler example to help us understand. Okay, I made up this graph, but to make a point. If I wanted to know the ordered pair of that y-intercept, we know it crosses at 1, 2, at y equals 2. So that means the ordered pair of that location, if you were to graph it, it didn't go anywhere left and right, is 0, 2. So at the y-intercept, x equals 0. So at the y-intercept, x equals 0. Now, that actually makes sense. At the y-intercept, x equals 0. So if you were to plug in a 0 right here for x, if you were to plug in a 0, you'd have negative 60 times 0. Well, it doesn't matter if that is. Anything times 0 is 0. So if you plug in a 0 for x, all of this is 0. And so you would be left with y equals 270. So that means the y-intercept is 270. Oh, but look, what we just said, we already knew that because we learned that from the pattern of how slope intercept form works. So that's how we got this y-intercept of 270. We already knew that. Now, for the other one, for the x-intercept, over here, the ordered pair of that x-intercept, remember, the side unrelated question, is 3, 0. So at the x-intercept, y is 0 because you're on the x-axis. You haven't gone anywhere up and down, so y is just 0. So algebraically, if you want to find the x-intercept, you can do this by making y 0. So we're going to take this equation, our original equation we wrote, we're going to make y 0, and that's how we're going to find the x-intercept. So instead of y, we're going to have an x, is what we're going to have. So, I'm sorry, I said x, I meant 0. Instead of a y, we're going to have a 0. We're going to plug in for it. So we're going to have 0 equals negative 60x plus 270. If you now solve this for x, that answer will be your precise, no opinion, no guessing, your precise x-intercept. So to solve for x, you got to get rid of plus 270 first. So to get rid of plus 270, we subtract 270 from both sides. So subtracting, they cancel on the right side. This is just your equation skills. We're left with negative 60x on the right side. And on the left side, 0 minus 270, that's negative 270. So we have negative 270 equals negative 60x. So now to finish solving from here, hopefully you remember, in order to get rid of any coefficient, we have to get rid of negative 60 as a coefficient. When they're touching, that means multiply. to get rid of any coefficient, you have to divide both sides by that number to get rid of it. So you're going to divide both sides by 60. So 270 divided by 60. Okay. All right, so that tells you if you divide both sides by negative 60, you got to move the whole thing. Divided by negative 60, divided by negative 60, they cancel on the right side. So now you're going to be left with x equals, now on the left side, a negative divided by a negative is a positive. 270 divided by 60, or 27 divided by 6, that's going to come out to 4.5, or 4.5. So 4.5 or 4.5. So we were solving for hours, so that tells us 4.5 hours. So that tells us 4.5 hours, so 4.5 hours, or you can say 4.5 hours. That is the x-intercept. So now that's the answer to number 4. The x-intercept is located at 4.5 hours. So 4.5 hours. Now they asked us, what does that represent? What does the x-intercept represent? Now that tells us the x-intercept. Now before I go anywhere, I want to point out my graph you'll see, because remember I kind of estimated it, was not fully on. It's supposed to cross at 4.5, which means so that's right here. So that line needs to go through 4.5. There we go. Now it's much more accurate. Okay, so now that graph tells us, the x-intercept tells us at 4.5 hours, that's the x-intercept. That tells us after 4.5 hours of driving, we have, let's check the graph, 0 miles remaining. That's what that tells us. And intuitively, y was the number of miles remaining. So when we made y 0, that tells us when we have no miles remaining, we have 0 miles remaining, x is 4.5 hours, which tells us it's going to take 4.5 hours in order to go to the end of the drive his trip to get from West Palm Beach to Gainesville. So this was an example. This was an example, guys, of using slope-intercept form to graph an equation by step 1, identify slope and y-intercept. Step 2, graph the y-intercept. Step 3, graph the slope from the y-intercept. For most questions, you're going to have a much more detailed graph than this one. This one required a little bit of estimation. Sorry about that. Step 4, draw your line through those points and draw as accurately as you can. And if you're using graph paper and you're not having to estimate where that point is in between, you're not going to have an issue. You're going to be using a ruler or a straight edge or some kind, and it's going to come out perfect. And you're going to have a fantastic graph of graphing any equation using slope-intercept form. Now, what I'm going to do is I'm going to put up 2 questions, and I'm going to let you try them first. You're going to hit pause and try them. I'm not going to spend a long time explaining them. I've already kind of explained how they were. So I'm going to hit play, and then you'll hit pause, try it, and then I'm going to quickly run through the questions. For those of you that just want to see one more, you want to confirm you've got the hang of this. So again, I'm not going to spend a lot of time explaining them, so just know they should go by pretty fast. But at least check them out to confirm for yourself. You at least have the basics of how to graph with slope-intercept form. All right, so on the screen you'll see 2 questions, number 5 and number 6, of 2 equations that are in slope-intercept form. I want you to graph both of these. So hit pause, try these out on your own, graph them out on your own sheet of paper, graph paper preferably so you can be as exact as possible. Graph these questions and try to be as precise as possible. Just follow the steps we've done. And then hit play and see how you did. Awkward silence. Just kidding. All right, so I hope you hit pause and try these questions. So now I'm gonna run through the steps. We're gonna graph both these questions and knock them out. So these will be your final examples. Step 1, find the slope and y-intercept. So the y-intercept of number 5 is -2. So b is -2. That's what that tells us. That tells us that's gonna cross the y-axis down here at -2. The slope is m. So m is -3/2. So the slope is -3/2. That means from this location, go down 3/2. So 1, 2, 3/2. So right there. You now have your 2 dots. You are ready to draw your line. And remember, when you draw this line, you can try to draw it with a ruler. Make it as straight as possible. All right, so I'm gonna do my best to draw that line. Okay, got a little crooked, but I drew my straight line. So I have now graphed the equation for number 5. That is it for number 5, you're done. Number 6, let's graph this one. Step 1, slope and y-intercept. So let's see, y-intercept. Y-intercept is +7, so crosses the y-axis at +7. I should be doing this in a different color, I apologize for that. Okay, so +7, that way you know it's a separate question. I don't normally encourage doing your questions on the same graph like this. Okay, +7. The slope is going to be located at it's not located anywhere. The slope is -3. We need a denominator, let's make it 1. So that means down 3 over 1. So from, now step 3, from step 1, step 2 was graph the y-intercept. Now from the y-intercept, graph the slope. So that means we're going to go down 3 over 1. So 1, 2, 3 over 1. So our second point is right there. We're now ready to graph this equation. Give myself a couple more reference dots. 1, 2, 3. Okay. All right, that way I know I'm drawing my line straight. All right, so now from there, draw your straight line. Use a ruler, use a straight edge of some kind, and draw a line that goes exactly through those points. All right, so I'm going to go and do my best to go through those points. There you go. That's your line, kind of straight. I know I missed a little bit. I got a little curvy at the bottom, but that is the graph of this equation. So that is how we go from y equals negative 3x plus 7 to the graph of y equals negative 3x plus 7. This was hopefully your final examples where you really got the hang of it. This answers your question, how to graph slope-intercept form. Now, a final note I'm going to leave you with, remembering our function notation from yesterday. If this question said f of x equals negative 3x plus 7, the way you would have solved it was, wait for it, exactly the same. If it said graph this function and use that fancy f of x instead of y, everything you would have done to graph it would have been exactly the same, no change. Because remember, f of x is the same thing as pretty much saying y. It's the output, the value of the function. So even if for number 5, if it said f of x instead of y, made it look fancier, it's exactly the same. All right, guys, so practice. Y-intercept, graph your slope from the y-intercept, draw your line, you're done. Good luck, guys, and take care.